I'm welcoming to everyone for a topic in Zeroth Law of Thermodynamics in Aeroengineering Thermodynamics. Myself, N. Venkatesh, working an assistant professor in SNS College of Technology in the Department of Aeronautical. These are the learning objectives of in Zeroth Law of Thermodynamics. Before we discuss about this one, first we know the basics of Zeroth Law. The zeroth law of thermodynamics states that if thermodynamic systems are each in a thermal equilibrium with the third one, that they are in thermal equilibrium with each other. Accordingly, the thermal equilibrium between system is a transitive relation. The two systems are said to be in a relation of thermal equilibrium if they are linked by a wall permeable only to heat and they do not change over the time. As a convenience of language, systems are sometimes also said to be in a relation of thermal equilibrium if they are not linked so as to be able to transfer heat to each other, but would still not to do if they were connected by a small permeable only to heat. The physical meaning is expressed in by the Maxwell words all heat is of the same kind. Another statement of the law is all isothermal walls are equivalent. The law is important for the mathematical formulation of thermodynamics, which needs to be the assumption that relation of thermal equilibrium is an equivalence relation. This information is needed for a mathematical definition of temperature that will agree with the physical existence of valid thermometers. A thermodynamic system is by definition in its own, there is no change in observable state over time and no flow occur in it. One previous statement of the zeroth law is that relation of thermal equilibrium is an equivalence relation and pairs of thermodynamic systems. In other words, the set of all systems each in one state of internal thermodynamic equilibrium may be divided into subsets which may every system belongs to the one and only one subset, and that is a thermal equilibrium with every other member of the subset, and is not a thermal equilibrium with a member of any other subset. This means that a unique leg can be signed in every time. If a defined as a thermodynamic system in thermal equilibrium with itself, then the zeroth law may be stated as follows. If a body C be in a thermal equilibrium with two other bodies A and B, then A and B are in thermal equilibrium with one another. This statement asserts that the thermal equilibrium is a left Euclidean relation between thermodynamic systems. If we also define that every thermodynamic system is in thermal equilibrium with itself, then thermal equilibrium is also a reflective relation, binary relation that are both reflective and educational or equivalent relations. In empathy part of an thermodynamics is one consequence of an equivalence relation is that the equilibrium relationship is symmetric. If A is in the thermal equilibrium with B, then B is in the thermal equilibrium with A. Thus we say that two systems are in thermal equilibrium with each other or that they are in thermal mutual equilibrium. Another consequence of equivalence is that thermal equilibrium is a transitive relationship and is occasionally expressed as follows. If A is in thermal equilibrium with B and B is in thermal equilibrium with C, then C is in thermal equilibrium with C. A reflective transitive relationship does not guarantee an equivalence relationship. In order for above statements to be true, both reflectivity and symmetry must be implicitly assumed. The foundation of a temperature, the zeroth law establishes the thermal equilibrium as an equivalence relationship. An equivalence relationship on a set that the thermal equilibrium divides that set into a collection of existing subsets, where any member of the set is a member of one and only such a subset. In the case of the zeroth law, the subsets consist of systems which are in mutual equilibrium. This patinating allows any member of the subsets to be unequally tagged with a label identifying the subsets to which it belongs. Although the labeling may be quite arbitrary, temperature is just such as a labeling process which uses the real number system for tagging. The zeroth law justifies the use of sustainable thermodynamic systems as thermometers to provide such as labeling which yield any number of possible empirical temperature scales and justifies the use of the second law of thermodynamics to provide an absolute thermodynamic temperature scale. In the space of thermodynamic parameters, zones of constant temperature form a surface that provides a natural order nearby surfaces. One may therefore construct a global temperature function that provides continuous ordering states. The dimensionality of a surface of a constant temperature is one less than of the number of thermodynamic parameters. Thus, for an ideal case described with three thermodynamic parameters P, V, and N, it is a two-dimensional surface. For example, if two systems of ideal case are in equilibrium, then other two cases is equal to the same. The surface of a constant defines the surface of equilibrium thermodynamic temperature and may label defining T so that where R is some constant. These systems can now be used as a thermometer to calibrate other systems. In a sense focused on zeroth law, there is only one kind of diathermal wall of one kind of heat as expressed by Maxwell's dictum that all heat is of the same kind. But in the another sense, heat is transferred in different ranges as expressed by Sommer's dictum. Thermodynamics investigates the conditions that govern the transformation of heat into work. It teaches us to recognize temperature as measure of the work value of heat. Heat of higher temperature is richer, is capable of doing more work. Work may be regarded as heat of an infinitely high temperature as unconditionally available heat. This is why temperature is particularly variable indicated by the zeroth law statement of equivalence. So physical meaning of the usual statement of the zeroth law. The present articles states that the zeroth law of summarized textbooks and will be a famous one is a Maxwell for the empathy you speak clearly be distinctly in that test. In our defined part, thermodynamics says that if two thermodynamic systems are in each thermal equilibrium with the third one, then they are in thermal equilibrium with each other. Accordingly, thermal equilibrium between system is a transitive relation. Yes, here is explain will be given by the ourselves. The zeroth law establishes thermal equilibrium as a equivalence leadership, and equivalence leadership and set divides that set into a collection of distinct subsets. The patrioting allows any member of the subsets to be uniquely lagged with the label identifying the subset to which it belongs. Although the labeling may be quite arbitrary, temperature is just such as a labeling process which uses the real number system for tagging. The zeroth law justifies the use of the suitable thermodynamic system as thermometers to provide such labeling, which yield any number of possible empirical temperature scales, and justifies the use of the second law of thermodynamics to provide an absolute or thermodynamic temperature scale. Such temperature scales bring additional continuity and ordering. In the space of thermodynamic parameter, zone of constant temperature form a surface that provides a natural order of nearby surface. One may therefore construct a global temperature function that provides a continuous ordering of states. The dimensionality of a surface of a constant temperature is one less than the number of thermodynamic parameters. Thus, for an ideal case described with three thermodynamic parameters. For example, if two systems of ideal cases are equilibrium, then the third one is also equilibrium. The present article says that the zeroth law is often summarized in textbooks. Nevertheless, these useful statements perhaps does not explicitly convey the fulfilled physical meaning that underlies it. The underlying physical meaning was perhaps first claimed by Maxwell's. In Catherine's theory, the postulated of the existential permeable of heat. According to the Arnold Sumfold history, the zeroth law of thermodynamics, when he was discussing in 1935 text of Magnet Saga and measurable in numerical terms, the pressure that the temperature is a physical quantity and the deduced the statement if a body of a thermal equilibrium B and C and with each other with a C, then The thermodynamics of Otto cycle will be explained in a recommendation by the scientist Otto. In this regard, the equilibrium of thermodynamics states that if two body is also with third one, this says is essence three bodies of all temperature. A heat is of the same kind. What is most important, the zeroth establish that temperature is fundamental and measurable property of water. And the main history of zeroth law is when the law of thermodynamics were originally established, there were only three. This is our immediate section in zeroth law. The alternative calling this law of fourth law and putting it on this list was also problematic because it superseded the other three laws. But scientist Ralph Hirschflower come up with third alternative that solved the dilemma he called the new law of zeroth law. According to the David McKay, a professor in physics of Missouri and Southern State University, the zeroth law tells us that no matter how many energy two systems having knowing how much energy they have doesn't let me predict which the directions heat will flow. If I am putting them, the zeroth law says that this number, which is temperature, defines the direction of heat flow and it does not depend directly on the amount of energy that's revolved. He continued that temperature of two systems is the only thing you need to know in order to determine which direction heat will flow between them. It's a thermometers. Even the simplest one called plants, animals respond to changes in temperature. The concept of hot and cold, as well as the hotter and cold, and the problem through was how to describe temperatures with enough precision to be useful. This requires a repeatable method for a measurement on incremental scale. The zeroth law of thermodynamics defines temperatures and makes thermometers possible. For a thermometers to be useful, though it must be first calibrated. All other basic units of measure, example for length, mass, time, etc., are each defined according to the precisely standard. In this case, we must not only define a unit of measure but also the beginning point of the scale. The most notable early efforts to standardize temperature measurement were those of Daniel Gabriel Fahrenheit. In the early 18th century, Fahrenheit invented the familiar glass tube type thermometers using both alcohol and mercury. He also invented the Fahrenheit scale, which sets the freezing and boiling points of water as 32 degrees and 212 degrees respectively, and is still used to this day, particularly in the United States. Most of the rest of the world uses the Celsius scale, which assigns values of 0 degree for the freezing point of water and 100 degrees for its boiling point at mean sea level. All measuring scales used in science and engineering start at a value of 0. The concept of zero length, mass or time relatively easy to grasp. However, zero temperature, absolutely whatever it is more difficult to grasp. This is because such temperature has never been observed in nature or in the laboratory, and it is generally believed that it never will be. However, scientists have gotten quite close. The unit of the temperature is Kelvin and defined according to the triple point of water, which is equal to 0.01 degree Celsius, 32.01 degree Fahrenheit. The triple point is defined as the particular temperature and the pressure at which the solid, liquid and gaseous phases of a given substance are all at equilibrium with one another. It was chosen as the standard largely because it can be easily reproduced physically in a laboratory, whereas the temperature of the freezing point of water can be affected by a number of confounding variables. The National Institute Standard Technology defines the Kelvin as the fraction of 1 by 273.16 of thermodynamic temperature of triple point of water. In a prototype, we make it a two-part. These are called water and cold water and thermometers for using the test. Most thermometers contain liquid or metal that changes volume or shape depending on its temperature. When the liquid or metal reaches a thermal equilibrium with the object or substance being measured, the temperature sensitive properly of the material in the thermometer can be exploited to the indicated by its temperature. For instance, some type of thermometer use a liquid, typically alcohol or mercury, which expands or contains with increasing or decreasing temperature. The small expansion is simplified by having a relatively large reservoir of liquid in glass bulb connected to a long and very narrow glass tube. In this way, a small change in the volume of the liquid in the bulb can cause a large change in the level of the liquid in the tube, so that the temperature can be determined by reading the height of the liquid against a calibrated scale. Another type of thermometer is based on the thermal expansion of metal. Again, the problem is how to amplify a very small change in size so it can be read on a scale. One way is to use a coil with many loops, as so slight change in length is multiplied by the number of loops. Another type exploits the fact that different metals expand at different rates when heated. Strips of two different metals with the different coefficients of expansions can be laminated together so that the assembly will curl when it is heated. This deflection can move a needle that can be read at against a scale. And the reference links is related with the Zeroth Law of Thermodynamics is exposed about the measuring of temperature relies on color changes in temperature sensitive organic materials. These are the typically useful for measuring limited temperature ranges, such as indicating fever monitoring group temperature. Another device called a thermometer works based on changes in the electrical viscosity of the semiconducting material due to its temperature. These devices can detect extremely small temperature changes and are used to in bolometers and to monitor laboratory equipments. However, so the measurements would be possible without relying on the participant described in the Zeroth Law of Thermodynamics. For our additional explanations, these reference links will kindly explain about what are the Zeroth laws and what is the experiments will have and what are the advantages and disadvantages of Zeroth law of thermodynamics. The total fully explained by this concept. The statements of thermal equilibrium is a left Euclidean relation between thermodynamic systems. If we also define that every thermodynamic system in thermal equilibrium with itself, then thermal equilibrium is also a reflexive relations, binary relations that are both reflective and equilibric relations. Thus, again implicitly assuming reflectivity. In Zeroth Law of Thermodynamics, equilibrium may be divided into subsets in which every system belongs to one and only one subset, and it is the thermal equilibrium every system, and if it tanks of two systems are the same, they are in thermal equilibrium with each other and it's different, they are not. This property is used to justify the one empirical temperature as a tagging system. Empirical temperature provides further relations of thermal equilibrium system such as order and continuity with regard to hotness or coldness, but they are simplified in the standard statement of the Zeroth law. One consequence of equivalence relationship is that equilibrium relationship is symmetric. If A is in the thermal equilibrium with B and B is the thermal equilibrium with C, then the two systems are in thermal equilibrium with each other, or they are in mutual equilibrium. In the space of thermodynamic parameters, zones of the constant temperature from a surface that provides a natural order nearby surfaces, one may therefore construct a global temperature function that provides a continuing ordering of states. The dimensionality of a surface of constant temperature is 1 less than the number of thermodynamic parameters. Thus, for an ideal case described with three thermodynamic parameters, pressure, volume, and temperature. This is the Zeroth law of thermodynamics functions. The surface of focused in the Zeroth law, there is only one kind of diathermal wall or one kind of heat. It is exposed in the teachers to recognize the temperature as the measure of the work value of heat. Heat of higher temperature is richer, is capable doing more work. Work may be recorded as a heat of an infinitely high temperature unconditionally available heat. This is why temperature is particularly variable, indicated by Zeroth law of statement. The ideas may be regarded as helping to clarify the physical meaning of the useful statement of Zeroth law of thermodynamics. It is the opinion of deviation of statistical mechanics of the law of entropy increases is a goal that has no far eluded the deepest thinkers. Thus, the idea remains open to consideration that the existence of heat, temperature are needed as a coherent primitive concept for thermodynamics. Thank you.